Here's the first problem on page 13. I call this a typical way of doing a problem and the cool way of doing the problem. This guy bought something for $2,400. He's got to pay 7.8% sales tax in addition to that. Typically, what we do is multiply the 2,400 by 7.8% change to a decimal by moving the point 2 places to the left. The 0 to the left of the decimal is not necessary, but we put it there sometimes to call your attention to the decimal point. So when you do 2,400 and you multiply that by 0.078, you get the tax 187.20, and the calculator doesn't put a 0 there, but when you report your answer, you really would. And then I'm going to add that to 2,400. And I get $2,587.20. That's 2 dimes, not 2 pennies. All right, so, but the cool way is just to multiply 2,400. If you multiply it by 1, you get to 2,400. And if you put 0.078, then that will calculate 1 plus the tax, 1 times 2,400. In other words, this is 107.8% of 2,400. And that turns out to be $2,587.20. And again, no 0 on the calculator, but we report the 0 when we turn our answers in. The reason we need to know the cool way is this. Sometimes you have a problem where you know what the price is with tax included. Like this, for example. How do you get back to the original price if you know that this is 107.8%? Then you would just divide that by 1.078, and that's how you get back to 2,400. For example, here's something that's purchased for $60,737.50, including tax. What you don't do is take 7.5% of $60,737.50 because it just doesn't work. What does work is to take 60,737.5, put the 0 there if you want to, and you realize that that is some unknown number plus 7.5% of that same unknown number, and you do not get back to that taking 7.5% of 60,000 plus. The only way to do it that makes sense is to divide it by 1 point the tax rate, 1.075. And guess what? There's the actual answer. Now the tax is going to be 7.5% of that number, which is just a difference. All right, next. This problem is a percent decrease problem because the price went in 1999 from 630, but 4 years later it went down to 430. Now, this is the same formula whether it's a percent increase or decrease. You subtract the two, the smaller subtracted from the larger, and you divide that by not the big one, the little one, the older one, the original one. So that's what this is. This $200 difference is $200 less than the old price, which means it's a percent decrease, and the percent is always taken of the older price. So you got to divide that by 630, and you get 0.3174, and it says round to the nearest 0.1%. What that means is move the point 2 places to the right, and then round off to the nearest digit to the right of that 1, and it's a 7. You'd make it an 8 if that were not 4, but if it were 5 or more, then you would make it 31.8%. Number 4. This is, believe it or not, just like problem 2. Really, yes. You want your $7,000 in the bank by putting in how much? We don't know, but they're going to give you 6% simple interest, which means if you leave it in for 1 year, you will get your money back, of course. You will also get 6% of your money you deposited. That is not 6% of 7,000, so don't do that. The only way to, there is no right way or wrong, there's the only way to do this. There's lots of wrong ways. The only way to get this right that makes sense is to say, okay, 7,000 is some unknown number plus a 6% of that unknown number, which is 106% of it. And that's why you divide that by 1.06. I put one more digit to the right in case I wanted to round it to the nearest penny, but it says round to the nearest dollar. So you only look at the very first digit to the right of the point is 7, and that is 5 or more. Therefore, it rounds to 6603. All right, this sausage problem, believe it or not, has things in common with other problems on these 2 pages. And here's why. There is an unknown amount of meat in this recipe, and 40% of it's going to be pork and 35% of it beef, and then the rest, and that's the key. What's the rest? Well, the rest is the 225 pounds of venison. Now, percentage-wise, when you take 40% and 35% away from 100%, that's the same thing as taking 75% from 100%, and that leaves you with 25%, which is 0.25 as a decimal. So that means that the venison represents the other 25%. So 25% times something has got to equal 225. And the way you figure that out is you take 225 and you divide it by. And don't forget to look at every single number you punch into your calculator, and there is a 900. Some of you notice that 25% is 1/4. So could you multiply 225 by 4? Yes, you can. However, that's because 25% is a nice, easy one. What if it were 36%? Then what are you going to do? Then you'd have to divide by 0.36. So there's the 315. And by the way, 40% of that is the beef. Oh, this is not the answer to the problem. But if you put that over there for your answer, it's going to be wrong because it says how much beef. It doesn't say how much. Oh, okay. So the amount of beef is 35% of the total. And so that means it's 315 pounds. Just to show you how that works, I put that in memory. And the problem solved, it's done. But to show you why this works, you can take 40% for the pork of 900, that's 360, and add that. Then you can take 25% of 900, believe it or not, and that is going to be, guess what, 225. Oh yeah, you add that to memory, and what's in memory now, there's the whole 900 pounds. 35% of it's beef, 40% of it's pork, and 25% of it is venison. Very cool. Number 6. This is one of those like numbers 2 and 4. In that there's some unknown number, which is the price before tax. That unknown number is increased by 7.75% of itself. That means that the unknown number can be calculated by realizing that $9.45, you don't take 7.75% of that because that's not the price before tax. The price before tax is unknown, but whatever it is, $9.45 is 1 times it plus 7.75 or 0.0775 times it. So you have to divide it by 107.75 as a decimal, and you get $8.77 to the nearest penny. Now, that's all I asked was I believe all I asked for is the tax. So don't put 877. No, you have to subtract that from $9.45 and get 877. All right. Hold on. What you have to do is take the $9.45 and subtract the $8.77 and wind up with 68 cents. Now, you can either put $.68, 68 hundredths of a dollar, or 68 cents, but do not put 0.68 cents. Not good. Now, if you are also asked for the cost, sometimes I ask for 2 things. How much is the tax? And how much is the cost of the donuts or whatever it is before the tax? Then you would report both of those numbers. If you only report one of them, you will lose half the points. Not good. The other way to get the tax is to take the 877, which is before tax, and multiply that by 0.0775. 775, and you wind up with 0.679, but to the nearest penny, that's 0.68, which is 68 cents. All right, number 7. This is a case of a number, an unknown number called the selling price, and it's split into 2 parts. One part goes to the dealer, 20% of that, and the other part is going to the actual owner of the vehicle. The owner of the vehicle says $54,000 is what I need to have after you take your commission. What that means is the 54,000. By the way, do not multiply 54,000 by 20% and then add that on, because if you do, that's a bigger number than 54,000, and you'll get more than you would otherwise. Okay, what you have to do is divide that by the other 80%, because 54,000, when 20% goes to the dealer, what's left is the other 80%. And so 54,000 is 80% of something. So that means it's something times 0.8, which you discover by dividing that by 0.8. And that's how you get 67,500. And that is what the dealer gets 20% of. All right. This one's complicated, but there's 2 kinds of problems, that it's actually similar to. The first calculation is similar to problems 2, 4, 6, where you have a number that's more than 100% of something because tax is added. And then the other one is 5, 7, 9, and 11, which is you have something that's been decreased by 5%. So what we have to do first is take the total out the door price of $12,700 and subtract the $388 in fees. And then let's do that on the calculator. 12,700 subtract the $388 in fees. And pay attention to the pennies. Sometimes the fees have pennies on there. You got to include that as well. Now, I need to say equals right now, because if I say divided by, and this calculator does order of operations, it will divide 388 by 1.08. But I don't want it to do that. I want to calculate that first. And then this number has tax included of 8%. That means that this number, 12,312, is some number plus 8% of that number. So this is 108% of some number. So I divide it by 108%, change to a decimal. And that gives me 11,400. Okay, that is sale price, which means it's not the sticker price. Sticker price is 5%, well, 5% off the sticker price, but you cannot take 5% of 11,400 and add it on. It doesn't work. You have to realize that 11,400 represents the unknown sticker price takeaway minus, in other words, 5% of the unknown sticker price. So this is the 95% that's not taken away. 5% off means 95% on. So I got to divide that by 0.95 to see what that's 95% of. Look at every number you enter on the calculator. And that answer is $12,000. Number 9. Here's another one like number 5, 7, and 11. I put that down for your convenience so you can see how they are related. Person's going to buy a new kitchen, needs $47,000. This is just like the problem about selling the car. She needs $42,000 after paying the IRS 33%. Here's the key wording, of the amount withdrawn, not 33%, not 33% of what she wants left over for her share. So you have to realize that the 42,000 represents a number decreased by 33% of the unknown number. Do not take 33% of 42,000 and add it on. It doesn't work. What you have to do instead is take 42,000 and realize that that is the other 67% of something. So it's some number times 0.67. Don't put 67. That would be, you got to put it as a decimal. And that number is 62,686 and 56 cents. It would be 57 cents if I didn't tell you to round it. But guess what? I did, to the nearest dollar. Aha. Well, the dollars place is where the 6 is. And just the first digit to the right is 5. And that's enough to bump it up to a 7. That's why it's 62,687. Now, if that 5 were a 4 instead, You don't say, well, the 6 would round the 4 to a 5, then the 5 rounds to 6. No, that doesn't work that way. If that's a 4, this remains a 6. All right, there are 3 problems that are similar to this one. One of them is Spurs. You don't have to be a Spurs fan or a sports fan at all in order to work this problem. You've got 2 categories. You've got your wins and your losses. It could be good eggs and bad eggs. It could be men and women. It could be chickens and ostriches. But there's 30 in one group and 52 in the other. So what percent of their game will they have won? Well, how many they won is 30. So you put the number of wins divided by, guess what? The number of games. Aha, 30 wins and 52 losses means they played 82 games. So if you take the number of wins and divide it by the number of games and look at every number you plug into your calculator, you get that. Now it says, write the answer to the nearest 0.1%. And if you don't do that, if you just say, well, you know what, I'm not doing it, I'm going to put 37%. No, changing that to a percent means you move the point 2 places to the right, which is equivalent to multiplying by 100. The nearest 0.1%, here's what you do. Change the number to a percent, look at the first digit, look at the second digit. If the second digit is 5 or more, you bump that first digit to the right of the point up 1. That's why it's 36.6, because 8 is big enough. Tricky one. This is another example of you have a number which is unknown. That's the total budget. The total budget is unknown. Since it's unknown, you can't take 10% of it. In particular, 10% of the total budget is not 10% of 8.5 million. This is the way a lot of people work it. So what do you have to do? You have to realize it says 10% of the total budget is the college's share. The remainder is the other 8.5 million, which is 8,500,000. That's 8.5 million. That is the other 90%. Again, don't take 10% of that and add it on. It won't work. So this one is 90% of the total budget. So you divide that by 0.9 and you get that. Now you can do one or two things. You can either subtract 8.5 million, which will give you the same answer as multiplying by, well, the college's share is 10%, that's 0.1, and there it is. Now it doesn't say to round it off to the nearest anything, therefore you round it off to the nearest penny, and that means the second place is where that 4 is. It would only go up to a 5 if the digit to the right of it is 5 or more, but it's not. And that's why that's the answer. Number 12 is a very similar problem to the Spurs winning and losing. In this case, they won 105 and lost 55 over the last 10 years. Okay, well, I want their winning, if I want their losing percentage, I'd put 55 up there. But if I want their winning percentage, I put the number of games won divided by the number of games played. And 105 wins and 55 losses means they played 160 games. So I take my handy dandy calculator and I take 105 divided by 160. Oops, I forgot, I didn't do my own rule. Take my 105. I'm a bad calculator today. They take 105 and dividing that by 160. And we get that. Now it says express your answer in 2 ways. If you don't do that, if you only express it in one way, even if it's right, you're going to lose half the credit. Why? For not answering the question. Express it as a decimal rounded to the nearest 0.001. Here's what that means. Imagine 0.001 is next to this 0.001. That's what that means. That spot right there. The number to the immediate right of that is 2, which is not 5 or more. So you do not bump it up to 0.657. You leave it like it is, 0.656, which is what I did here. Now, to change it to a percent, you would move the decimal point 2 places to the right, which, as I mentioned recently, is multiplying by 100 on the calculator. So that is 65.625%. And the nearest 0.1%, well, now that it's a percent, the nearest 0.1% is where that 6 is. However, The 2 is not large enough to bump that up to a 7, so it's 65.6%. Again, if you only report this in one way, you're going to lose half the credit. This is a very similar problem. You got the college population split into 2 groups, the men and the women, 105 men for every 55 women. Now, that doesn't mean there are exactly 160 people. However, imagine that there are X groups of people, and every one of those X groups, like maybe 150 groups, has 105 males and 55 females. So that would be like 55x over 105x plus 55x. Oh, that'd be 160x down there and 55x there. It doesn't matter what x is. You will get the same exact answer. 55 divided by 160. Why did I pick 55? Well, because it asks for what percent or female, 55. Aha, that's why I divide by 55. Now, I change that to a percent, which means move the decimal point 2 places to the right, which means on the calculator, multiply it by 100. And that's going to be, it says the nearest 0.1%. But if you don't do that, well, then you're going to lose points, maybe all of them. So the nearest 0.1% is where the 3 is, and the 7 is big enough to bump the 3 up to a 4, and that's why it's 34.4%. Isn't this fun? Problem 14. Believe it or not, this was similar to a lot of things, but it's such a complicated problem. I just want to talk about it so that you will understand it when you get it. I got this problem from a friend of mine who is an actual home builder, and this is how he runs his business. He says, okay, look, I sell a house for whatever I sell it, and 5% of the selling price, and that's crucial, of the selling price. 5% of the selling price goes for insurance, 2% for salaries, 25% for advertising, and 3% for advertising. Sorry, I said that wrong. 5, 2, 25, 3, and the rest is for lot, labor, and materials. Okay, now here's what you know. The lot is $27,000 bucks. The labor is 600 hours at $21 an hour, and the materials of $105,000. And then round it off as, okay, now these little 5, 2, 25, and 3, those 4 things total 35%. Oh, so then 100% of the selling price, take away 35%, leaves 65%. That means that the lot, labor, materials, that's the other 65%. So how do I do that? Well, I recommend if you have a calculator like this and you have 3 things to add up, one of them is going to be multiplied by something. So 600 hours, I do that first. I just like to, times 21 bucks an hour. Look at every number. That's $12,600. So I'm going to add to that labor. I'm going to add the lot, which is $27,000. Then I'm going to add the materials, which is $105,000. And I get $144,600. That is the lot, labor, materials. And since those other things represent 35%, this is the other 65%. So the selling price times 0.65 is equal to that. So that divided by 0.65 is the only way that makes sense to work this problem. However, if I didn't say to round it, you'd put $222,461.50, guess what? 4 cents, because the 8 is big enough to bump it up. But I said round it off to the nearest $100. And the reason I said that, in real life, you're not going to see a house that's for sale and they put all the way down to the nearest penny. That's just not done. You could do it, but it gives you information. You could say, well, you know, I'm going to try to get 222,500. You might say, I'm going to try to get 223,000. Whatever you want to do, it's a decision-making instrument. That's what you do this for. And if you don't round it off like I asked, you will lose points, which I know you hate to lose. 15 is another one of those where you have 2 categories, pass and fail. Now, you can't have 0.3 students. You have 25 or 26, but 25.3 students doesn't make any difference. But suppose there were 253, multiply that by 10, 253 students for every 1,000 who pass. well, then that sort of makes sense. But this is just the ratio. So if you add 100 to 25.3, because you want to know what percent pass, so that's why the 100 goes on top. 100 divided by 125.3. Be sure you look at every number. Gives you that. I'm going to change that to a decimal by to a percent by multiplying by 100. And it's 79.808%. But it says rounded to the nearest 0.1%. That's where the 8 is. Now, if the 0 had been 5 or more, then you'd make it 9. And just to make this complete, if that were 79, let me clear that, 79.8.9, I mean. If it's something like that, if you're going to round it off to where the 9 is, the 5 is big enough, but you can't put 2 digits where the 9 is. So then you would round it off to 79.0%. Nothing to do with this problem, just a matter of information for you. Problem 16. You've had this before. So you've got a class that has A's, B's, C's, D's, and F's. And you add all those together. 5 and 7 is 12, and 15 is 27, and 8 is 35, and 5 is 40. There's 40 grades. So you take each of these 5 numbers and divide them by 40, and you'll notice that they all come out even. So you move the point 2 places to the right, and that's what it means to round to the nearest 0.1%, as we've done multiple times. Okay, now when it gets to be 0.2, well, now how can you move it 2 places? You got to add a 0. Technically, you should put 20.0%, but I'll let you slide if it's exactly 20%. Now, these all come out even, but what if they don't? If they don't, this is a little extra here. This is not on page 13 or 14. This is on page 5 and 6. In this case, you've got 5, 17, 37, 43 students. So now you're going to divide by 43, which it's not going to come out even. It's going to have to be rounded off. Again, rounded to the nearest 0.1%. You move the point 2 places to the right, you get 11.62, and the 2 is not big enough to bump it up to 11.7. In fact, none of these are big enough till you get to the last one. Move it 2 places to the right, you get 4.65, and the 5 is just barely big enough, so it becomes 4.7%. And that is how you work all those lovely problems.